I think we're on. Right. Good day, everyone. Sunday lunchtime. I'm in trouble because I'm doing a video when I shouldn't be, but it will just be 10 minutes. Say hello, ma'am. Is this a wave? Okay. Right. Quickly, I'm going to do this video and let me share the screen. Share visualizer. Okay. So we're looking at the integration and differentiation of ln and e. Okay, just a reminder quickly, because if you can't differentiate, okay, you can't integrate. So the derivative of e to the x is e to the x. Okay, so if you differentiate e f of x, okay, in order to differentiate that, okay, you're going to have to, okay, it's just going to be e using the chain rule. It's going to be have to be times f dashed of x. Okay, and remember that the derivative of ln x, okay, is equal to 1 over x, but remember there's a restriction on a log that x has to be bigger than 0, and the derivative of ln f of x using the chain rule will be 1 over f of x times by f dashed of x. So both of those over here are just using the chain rule. Okay, right. A reminder of your log laws: ln a over b is ln a minus ln b, ln ab is ln a plus ln b, ln x to the n is equal to n ln x, and those laws also work for everything with the same base. So as examples, we're going to go do Mind-Born Maths, page 278. Okay, first of all, a quick recall of differentiation. We're going to do C, F, and I. Right, so go try those three quickly by yourself, and then come back and watch the video of it. Okay, on page 278. Off you go, press pause, and come back. Right, so the derivative of e to the x squared minus 3. Okay, well, it's just going to be the derivative of e function stays the same. So it's going to be e to the x squared minus 3 times the derivative of the inside bit, which is x squared minus 3, and the derivative of x squared minus 3 is 2x. Okay, so to make it pretty, you can just leave it as 2x e to the x squared minus 3. That's the derivative of that. Okay, I'm not integrating yet. Okay, the next one is find the derivative of ln 8 of x. Remember, there's a restriction that x should be bigger than 0 there, because that has to be bigger than 0. And that's simply going to be derivative of ln of a function is 1 over that function, so it's going to be 1 over 8x using the chain rule times the derivative of the inside function, okay, which is going to be 8. Okay, so it ends up as 8 over 8x, which is simply equal to 1 over x. Okay, right, so I end up with 1 over x as your answer. And then this one over here, remember, you guys messed this up in the exam. You can go and use, you could go use your basic rule and say differentiation rule, and so that's going to become 1 all over x minus 2 x minus 1 times the derivative of x minus 2x plus 1, and then you have to go use the quotient rule. You're welcome to go do that, yeah, but it's a bit messy. Remember, I said to you a million times, it's always easier to use your log laws first and then differentiate. So this becomes the derivative of ln, I use this the log law of division, ln a over b is equal to ln x minus 2 minus ln x plus 1. Now this is a lot easier to work with because you just differentiate them separately. So it becomes 1 over x minus 2. Well, the derivative of that is just 1. You can times it by 1, but it doesn't make any difference. Okay, minus 1 over x plus 1. But you can go see the memo in your textbook. They do it the other way. Okay, this is a lot easier. Remember, that would have been 5x minus 2. It would have been 5 over x minus 2. Okay, using the chain rule. So always, with differentiation of logs, use your log laws first. It makes life a lot easier. Okay, right. If we look at integration, okay, remember your basic laws of this. The integral of e to the x is e to the x plus a constant, right? That constant's at the bottom. That's the first thing over there. Okay. If I differentiate e to the x plus a constant, I'll just get e to the x. Okay. The integral of e to the f of x, okay, well, it's going to be e to the f of x, but then if you differentiated that, you'd have times f dashed x, so to balance it, you've got to divide by f dashed of x. Okay. The integral of 1 over x, Okay, well, what I have to differentiate to get 1 over x, it's ln, and we put the absolute value in so we don't have to worry about the restriction. So it'll be ln of the absolute value of x plus a constant. Okay, and likewise in the integral of 1 over f of x, will it be ln over f of x, which will give you, okay, if you differentiate, that'll give you 1 over f of x. But then you'd have to times by f dash of x using the chain rule. So when you integrate to compensate, you have to divide by f dash of x. You're often going to have to use a substitution as well, which is kind of doing the reverse of the chain rule. So, as examples, we're doing J, L, N, P, and R. Okay, from that same exercise of mindful maths. I would always would integrate. So your first one is the integral of 3e to the 6x with respect to x. So the first thing I would always do is take out the 3, and you get the integral of e to the 6x with respect to x. Okay, so keep that 3 there. What I have to differentiate to get to e to the 6x? Well, you're going to have to have e to the 6x. But then if you differentiate, you're going to have e to the 6x times 6. So to compensate for that, you're going to have to divide by 6 plus a constant. And if we make that prettier, we get a half e to the 6x plus a constant. Okay, just have to get that. Okay. Right, so you end up with a half e to the 6x plus a constant. It's just always compensating for differentiation when you're integrating. Always easier, there's no product rule, okay, for integration, so times out first. Basic rule for exponents, if you're multiplying powers, okay, you add the exponent, so it's going to become the integral of e, x plus x is 2x, plus 3 e to the x with respect to x, okay. And now, how do we integrate e to the 2x? Well, to get back to e to the 2x after I differentiate, I'm going to have e to the 2x times 2, so to compensate, divide by 2. Here, we take out the constant, and to get back to e to the x, this is going to be e to the x plus a constant. So there's your answer over there. Okay, you're going to have a half e to the 2x plus 3a to the x plus a constant. Okay, all good. Right. N, the integral of 4 over x, well, just take out the 4 and you get the integral of 1 over x with respect to x. Okay, remember, so that's going to become 4 ln of the absolute value of x plus a constant, okay, which alleviates the problem of the restriction, okay, on that over there. The integral of 4 over 5x minus 2 with respect to x, just take out the constant, so it becomes 1 over 5x minus 2 with respect to x, which is going to be 4, okay. The integral of 1 over something is ln of that thing, ln of the absolute value of that thing, but now you've got to compensate for the 5 using the chain rule, so you divide by 5, so there's your answer. 4 over 5 ln 5x minus 2 plus a constant, right? Just checking, yeah, that's right. Okay, and then the last one for the video, the integral of 2x cubed minus x over 4x to the 4 minus 4x squared with respect to x. Well, let's just get rid of that bit, make it a bit prettier by taking out a quarter. So you get 2x cubed minus x, okay, over x to the 4 minus x squared with respect to x. So a substitution will make our lives easier, because if we look, we differentiate that, okay, you're going to get 4x squared, okay, minus 2x. 4x cubed minus 2x, which can relate to this, I would think. So let's just check if that works. If I let u be equal to the x to the 4 minus x squared, then du dx is equal to 4x cubed minus 2x, but I want 2x cubed minus x. So if I divide by 2, I get du over 2 dx is equal to 2x cubed minus x. But remember, we want to replace 2x cubed minus x dx. So du over 2 is equal to 2x cubed minus x times dx. Okay, so that works out quite nicely, because that gets rid of the 2x cubed minus x dx. And we're nearly done. So I'm going to end up, this thing over here is going to become a quarter. And I'm going to replace everything. So 2x cubed minus 1 over x to the 4 minus x squared is 1 over u. That's that bit over there. Okay. And then 2x cubed minus x dx is going to become du over 2. Okay? We take out that, I get an 8th. The integral of 1 over u with respect to u. Now that's all pretty easy. The integral of 1 over u is ln u, so it's an 8th ln absolute value of u, don't forget, plus we don't have to worry about restrictions, plus a constant, but u is equal to x to the 4 minus x squared, so it becomes an 8th ln absolute value of x to the 4 minus x squared plus a constant. Okay. Double check I got that right. Absolutely correct. Right, guys. Please look on the WhatsApp group. Okay, or on the lesson plans, what homework you have to do. Okay, you've got to practice that stuff. As I said, with integration, makes life a lot easier. Right. Nice short 10-minute video. Good luck with that. Have a good day. Goodbye.
Lunchtime.